Good afternoon or morning, depending on where you're joining us from. Welcome to Retrofit Canada, presenting Retrofit Construction today. Just to let everybody know, we are recording this session. It will be posted all over our website and social media and YouTube after the webinar is done, so later this week or next week. And I just want to start with a land acknowledgement. We take this time to show our gratitude and respect to First Nations who have inhabited and cared for these lands long before today. We're grateful for their millennia of stewardship that has taken care of trees to give shade, water and food to sustain us, and paths to connect us. We recognize the unceded and traditional territories of many First Nations where we now live and work. So my name is Tim Wilson. I am the Executive Director of Retrofit Canada and very happy to be here hosting this webinar. This is our fourth webinar of the 24-25 season and our last one. And just to give you a bit of background about Retrofit Canada, so we are an open source nonprofit, meaning that we collect knowledge about retrofits and we share knowledge about retrofits. Our goal is to share solutions about getting these houses to net zero ready and eliminating barriers and accelerating retrofits across the country. So I am very excited today to start by introducing you to Fellipe Falluh. He is the founder of Retrofit Construction. He is the vice president of Passive House Quebec. Fellipe, I know that there is a correct French pronunciation of that name. I'll let you do that later because I will butcher it. Fellipe is also a podcaster. He is a Corporate Knights 30 Under 30 sustainability leader and a recipient of the King Charles III Coronation Medal. He has a degree in environment and civil engineering from McGill University. He comes from a family of Brazilian builders and is passionate about sustainable buildings. We also have Ben Hildebrandt from the Southern Alberta Institute of Technology's Green Building Technology Access Center. Ben is a building envelope expert and consultant. He's currently a principal investigator with SAIT, and he serves on the board of directors for Retrofit Canada. And then finally, today we will also have Peter Amarangan joining us. He is the president of Retrofit Canada. He has 45 years of experience in high performance building. He's a pioneer in net zero construction in Canada. He designed and built Canada's first net zero energy affordable multifamily project and church. He is a member of CHBA's Net Zero Council Management Committee, and he is also a certified passive house consultant. So today we have a very simple agenda. We'll start with an intro to deep retrofits from Ben. He'll go over some of the basic principles of getting a house to net zero ready. Then we'll have Fellipe presenting a case study from one of his recent projects. And then finally, Peter will help us get off on the right footing with our Q&A. And you will have an opportunity to submit your questions. Remember to post your questions using the Q&A button on your Zoom menu there. And then you can also vote for questions that you want us to deal with first. So with that, I'm going to turn this over to Ben. Ben, I'll get you to start sharing your screen now.
All right. Thank you, Tim. My screen showing up well there?
We cannot see your screen. We can see you. You look great.
You cannot see me.
I do see the screen. I had seen it.
You had seen it? All right. Okay. All right. So deep retrofits 101. So we want to just dive in, kind of cover some basics here on what a deep energy retrofit is. So one of the reasons we're looking at doing deep energy retrofits is to address provide reductions in Canada's greenhouse gas emissions. So from data from the Canadian Green Building Council, we see that buildings are responsible between the operations and materials in the construction or renovation of buildings. They're responsible for about 30% of Canada's greenhouse gas emissions. So when we look on the residential side, there's a lot of energy used. And when we look at reducing the emissions, we want to reduce that energy use. So if we look at the numbers for Quebec here for residential energy end use, so the actual use of energy within homes in Quebec in 2021, we can see that space heating was a very significant portion of that energy use. When we do deep energy retrofits, one of the key things we're looking at doing is reducing that heating and cooling load, so we can really cut down on those emissions and that energy use. And we also want to keep in mind too where these retrofits are taking place. So in Quebec, we know that's a very hydro dominant grid. So yes, there are emissions from that, but it's much less. But then we can also think about the other advantages of deep energy retrofits, which we'll get into in a little bit here. So across Canada, we are looking at over 10 million buildings that will need to be retrofit to achieve net zero energy performance by 2050 to meet federal climate goals. And to take a small chunk of that, between 1955, when Canada started tracking housing completions, in 1990, there's over 4 million homes just within that small segment of time. And that's a range where these homes are in a range to be retrofit right now. They're due for standard improvements, replacing of cladding, window systems, and just aesthetic upgrades. And so they're ripe for the retrofitting, to use a cliche term on there. But looking at that 4 million is less than half the homes that need retrofits. As we have the presentation from Fellipe today, we'll be looking at some older homes as well, older buildings that need to be retrofit. And how can we tackle those as well to accomplish this great goal of retrofitting over 10 million homes by 2050? So when we look at what a deep energy retrofit is, it's not solely just looking at reducing that heating load, but it's making a series of changes or improvements to the building to reduce its energy needs, so that energy that is remaining can be provided, or that energy load that is required still can be provided from emissions neutral sources. So when we look at what we are doing in a deep energy retrofit, first we look at improvements to the building envelope. We look at improving the air tightness. So that's addressing leaky windows. We have air leakage around outlets, attic hatches, various locations on the exterior walls of a building, that outer shell that of the enclosure. We want to improve the air tightness in those locations. That can be from specific ceiling efforts, point to point in different areas, or as you can see in the image on this slide, it can also be from just adding a whole new air barrier to the outside of a building as part of a retrofit to provide a nice uniform seal of the building. Then we look at upgrading, adding insulation to the building as well. We want to add that warm coat. And maybe that air tightness and insulation, we can swap that order. They're both very important. Air tightness, though, would be more important than insulation, because when you look at putting a nice warm winter parka on, like we did a couple months ago in the cold Canadian winters, we want to make sure that parka is zipped up nice and tight so we can get the full value out of the insulation we're adding on our building. And then with the envelope, we're also looking at improving the windows and doors. We want to make sure these are well insulating, and windows can be, in many cases, a thermal hole in the wall. So when we take the time to plan and specify higher performing windows, we can reduce the heat loss from those locations in the building envelope. Once we tackle the building envelope, we're often in these retrofits looking at electrification. There's a significant number of homes, even in hydro-dominated grids like Quebec or British Columbia, where the space heating is provided by natural gas furnaces. But we can look at changing that and installing upgraded and efficient heating systems that also provide cooling and providing proper ventilation, which is needed when we make these buildings more airtight. So heat pumps, HRVs, ERVs to provide the ventilation. So these are electrically powered systems to provide a well-conditioned and comfortable interior environment for homeowners. And then also we look at electrifying the domestic hot water systems in a home, standardly these days through heat pump hot water heaters. And then also look at electrifying our appliances. So these can be, we look at gas ranges or cooktops, fireplaces as well, though I don't think anyone would argue the fact that there's a significant difference between a gas fireplace and electric fireplace, but some people have been converted to enjoying the aesthetic of an electric fireplace still. But we electrify to make it possible for all the energy of the home to be provided from emissions neutral sources, whether it be a hydro-based grid or from solar right on the home as well. And then finally, that solar on the home, that renewable on-site energy generation is the last step of a deep energy retrofit. Once we've reduced that energy load, converted it to all electric, we can look at adding solar onto the top of a home to provide the energy it needs. The result we get out of a deep energy retrofit is often the goal we're looking at is net zero performance, where the home over the course of a year can produce as much energy as it consumes. So we know that net zero aspect is really capitalizing on the excess energy that's generated in the summer, which is going to counteract the energy that's still needed from the grid in the wintertime. So over the course of a year, our balance books for their energy provided to the grid and taken from the grid is going to be zero over the course of that year. And also when we look at reducing the loads before we go to net zero, where we do an envelope focused net zero, that leads us to providing minimal grid impact by reducing those loads. One of the concerns with electrification is how is that going to impact the utilities, the wires, the transformers that have to distribute electricity. And we also look at when we have solar on a home, that's great, but that's not going to produce in the depths of winter when it's really cold outside and it's nighttime. So as much as possible, as we can reduce the loads, we're going to reduce the peak grid impact and the adjustments and improvements that are going to be needed to the grid as the nation electrifies and retrofits their homes. Plus, there's beyond net zero and reducing that grid impact, there's many other benefits to a deep energy retrofit. And these need to be much more part of the conversation beyond just let's save energy and reduce emissions, because these are things that impact the day-to-day of the occupants of these homes. So we have improved occupant health. One of the key aspects of that is having an airtight envelope and having continuous fresh air through a heat recovery ventilator or energy recovery ventilator. We can have continuous fresh air within the home despite outdoor conditions when we utilize proper ventilation and filtration in those systems as well. We have improved thermal comfort. I often think about the impact of just having a warmer living room during the depths of winter where I can still curl up on the couch right next to the window and be comfortable without needing 7 blankets or what have you. We have the energy savings. We have reduced emissions. There's also noise reductions. When we add insulation to the exterior of a building and we also improve the air tightness, we're going to significantly reduce the noise from outside. And that's a key aspect that people are concerned about when they live next to busy roads. And then also, the last 2 points kind of meld together. We have the extended life of a building. Through a deep energy retrofit, we're renewing the exterior shell of the building. We're renewing the mechanical systems. We're essentially provided with a new building for all intents and purposes when it comes to the work we need to do on our homes to keep them operating. We can integrate climate resilience principles into a retrofit to make it possible for our homes to better weather the storms or climate events that they're susceptible to based on the location where we are, whether it's cold winter storms, high wind events, hail events, or fire events. Any aspect that might be impacted by local climate events can be addressed through a properly planned deep energy retrofit. And then finally, we have increased resale value. We're essentially left with a new home, and that impacts the value of it, just from the aesthetic renewal of a home and also the energy efficiency aspects and climate resilience aspects. Those, as we go on in time, those are going to more and more impact the resale value of homes as well. There's really only one kind of key obstacle to a deep energy retrofit that we can't brush over, and we need to acknowledge, and that's the cost. When we look at doing one of these, as some of us refer to as a one-shot deep energy retrofit, doing all the work at once, the costs for doing all of that, renewing the envelope, adding insulation, new windows, new cladding, new mechanical systems, and getting into the attic, addressing the roof as well, that can be $150,000 to $250,000 or even more. And that varies a lot depending on the specific home and the starting conditions that we're working from. And we need to acknowledge that and work with homeowners to kind of plan how that can be accounted for. And it's also a matter of perspective as well. When we have a home where the cladding needs to be replaced, the windows need to be replaced anyways, we need to consider that cost. And then what's that additional increase to add the energy efficiency measures to the work that already needs to be done. And then also we need to consider the total cost of ownership of the home. So we look at, we're going to reduce our energy needs. So after that retrofit, we're going to have lower annual energy costs for operating the building. When we select the proper materials or systems to be installed as part of a retrofit, we can also look at lowering the annual maintenance costs, what it takes to keep that home running, from a materials and system standpoint as well. So we can look at less cost to operate that home after the retrofit that can be accounted for in financially planning that retrofit as well. And one of the things we need to take into account is having properly planned actions or steps undertaken in a retrofit. We need to avoid piecemeal work where we're just doing one aspect here or one aspect there without really taking thought for what the overall retrofit plan is. So the image on the slide here is of one house which did undergo a panelized deep energy retrofit. You can read about it on the case study library from Retrofit Canada. But just 2 years before that full panelized deep energy retrofit, which included replacing the roof or building a new structure on top of the roof, just 2 years before, there were new shingles installed and a small solar array installed. So when it underwent that full deep energy retrofit later, all that work just 2 years before had to be fully removed, and part of that was wasted. We need to start with a proper plan for how we can complete a deep energy retrofit to ensure we're minimizing rework or wasted funds and wasted efforts on this. And that proper planning can ensure success. But there's a lot to look at with that. We start off with looking at where the building is at now. We complete energy modeling. We kind of go back and forth and how we can improve it, what the different options are, what is the best path to net zero for this particular home. To dial in, I like how Peter Amarangan puts it, what's the best 2050 net zero version of this home? We need to start with identifying that and then break down the steps it's going to take to get there and create a map, a roadmap to how that home is going to get to net zero, whether it's going to be all at once or whether we're going to break it down into well thought out and well-planned stages to get there, whether that's over a few years or even over a dozen years to capitalize on the life of existing materials within the home. We need to start with a great plan to get there. With SAIT and Retrofit Canada, we did a lot of work a couple of years ago. I think we're getting to a point where we're using the term roadmap a lot for a few different areas of retrofits. But this is the roadmap of a deep energy retrofit project as far as the key steps and processes are laid out. We need to start with a proper assessment of the home to see where it's starting from. And then we need to go through and do proper planning in how we're going to actually complete that deep energy retrofit. And then only after fully executing those first two phases do we get into the implementation or the actual completion of that retrofit project. So we need that assessment, that planning to ensure proper and successful execution and the implementation of that retrofit plan. When we look at a deep energy retrofit, there are dozens, if not hundreds of options of what can be done for a specific home. What are we going to use for the exterior wall insulation or the roof insulation? How are we going to address air tightness or mechanicals? What are the impacts going to be on the electrical systems of that home? Are we going to need to upsize the electrical service, go from 100 amp to 200 amp, or are there steps we can take to maintain a 100 amp service? Are we going to do that retrofit all at once, or does it need to be in phases? And are those phases 1 year after the other, or are we taking maybe several year breaks in between each phase? There's a lot of things that need to be considered. And starting with a strong plan is what's most important to ensure success in these deep energy retrofit projects. And we're working together between Retrofit Canada and SAIT, other organizations across the country as well, to look at sharing knowledge on deep energy retrofits. Retrofit Canada launched earlier this year a revamped case study library. We're calling it a repository of retrofit information. And these are from actual completed retrofit projects. So you can see what was done, where these projects started and where are they now? What was the energy improvement? What was the emissions improvements on on these homes, these buildings. The case study that Fellipe's going to present today is in that library as well. Also at SAIT, we're wrapping up right now the development of an extensive training program for contractors. We're launching the pilot in just another week here, and it'll be a full launch in the fall, partnering with schools across the country to make it available, so we can help scale up the retrofit industry in ensuring that these projects can be properly planned and properly executed. And all of this has been made possible with funding from Natural Resources Canada, and a lot of work's on the go right now. We're looking forward to a lot more work moving forward. And I'm gonna stop my soapboxing, my rambling here, and pass it off to Fellipe. Thank you.
Thanks, Ben. Awesome overview. I have checked out SAIT's curriculum, and it is awesome, and I can't wait for it to kind of hit the retrofit mainstream here in Canada. It's going to be very useful. Thanks for that, Ben. Fellipe, turn it over to you. But before that, I just want to say we've hit a very minor milestone in Retrofit Canada with Fellipe. We have published 2 of his case studies. They're in Quebec. This is, I think, only the second time we've done anything outside of Alberta where we have our roots. That's where we started. That's where many of our board members are based. Peter Amarangan, who helped found the organization, is from Edmonton. So we have an awesome base in the prairies, but we're moving east. So I was very excited to connect with Fellipe last year, and then to get 2 of his case studies in over the last month. So anyway, we're slowly making good on our national promise, and that's thanks to awesome partners like Fellipe. So Fellipe, I'll let you share your screen and get into your case study.
Absolutely. Well, thank you so much for having me, guys. First of all, Ben, great introduction. There's nothing else to add, honestly. Retrofits are complicated, but they're fun. They're really, really fun. All retrofits require sometimes different approaches, so there's no one size fits all. By having these discussions, by having these case studies, we'll for sure have a better idea of how to address each and every single home. So I really think that the work that Retrofit Canada is doing is super, super important for us to get to our retrofit goals that you mentioned in the beginning. So let me share my screen. Are we good? Does everybody hear me well and see the screen? Yeah? Perfect. All right, so let's start. So today I'll present to you one of our most recent projects, which by the name of Sucrerie Retrofit. So it's a project here in Quebec and in Saint-Agathe, which is basically an hour away from Montreal. So a bit more about us. So we are, sorry, Tim already presented me, but just to give you a bit of an overview. So we are a general contractor really focused on retrofits and retrofits only. We work on single family and multifamily retrofit projects. Sometimes we also just act as consultants if people want to do the work themselves or already have their general contractors and just want to make sure that they're following the right steps. We also do help, I say, in terms of window and building envelope sealing. Those are really most of the important elements of a retrofit. So whether it be also new construction, we do have an expertise in that. I also do, I am very involved with the Passive House community, which basically promotes very high-performing construction. So I am the vice president of Bâtiment Passif Québec, which is basically the Passive House chapter here in Quebec. We try to bring everything to the French language. And finally, I am the co-host of the podcast called Beyond the Walls, or in French, Au-delà des murs, which is basically all about high-performance construction. Again, trying to bring everything to Quebec. Quebec is a very specific province. I think it's very different. Every province in Canada has a different mission. I mean, we all have the same targets, but a different roadmap to that to reach that target. We do have, like Ben said, a big hydro grid. So I feel like our goals and our objectives are a bit different. And also we do have that big language barrier. So we try to break that language barrier as much as possible by giving as much information as possible into the French language. So a bit more about this project. Like I said, this project is an hour away from Montreal in Saint-Agathe. The client really came to us with a dream of a project, really to do a net zero project and no property. So really we started off by looking at properties with very good potential. I say that because every retrofit is technically feasible. We have the knowledge to really do any house and retrofit any house, but we don't have the necessary budget to do any house. So the viability of retrofits is very important to figure out and to really identify. So when we start with trying to identify a home, we try to identify a home with good retrofit potential, and we'll look into what is a house with good retrofit potential. So the clients wanted basically a retirement house that really matched their sustainable values. They wanted something that was eco-friendly, that was comfortable, that was sustainable, and that was energy efficient, right? So the project itself is an old barn that was converted, I think in 1965 into a house. So we do have like barn elements to it, but it was converted to a house. So it's a very ambiguous building, I would say. It's a Quebec construction. We'll be able to see a couple of pictures of it, but it's basically like an OG mass timber that we used to have here in Quebec. So the house in itself had a very great south-facing roof, and the siding and roofing were pretty much end of life. You could see here that like some windows were basically oddly dimensioned. There were some pieces of the siding that were really like also different types. The roof was leaking, so we were like, you know what, it's a good candidate for it. So for us, in terms of identifying the retrofit potential, here are the couple of elements that we really want to look at. First of all, I say old buildings, 30 years or more is something that, I mean, 30 years ago, we used to really build different, sometimes building with no insulation at all. So an old building has better potential, but sometimes not the case. I've seen some very new buildings with terrible building science, and the building is already in critical failure. Then at that point, I understand, but we try to aim for older buildings. This case, we had 70-year-old building, so it's a good it was a good metric that was met. Second of all, we want to look at either the interior or the exterior in a bad condition. So really, that's the delayed maintenance of it. In this case, really was the exterior that was meant. The interior too was also in bad condition, but the exterior in particular was a good case for an exterior retrofit. We don't want to try to have no major structural issues or really try to limit as much contaminants, because those are kind of costs that we're not putting directly to, I guess, to the retrofit part of the house, meaning the energy efficiency, the comfort, and everything. I mean, you can't always pick the right property, but if you can choose a property without structural issues, even better. Good solar orientation is good. It's very hard, I guess, and also in a building that's already existing. It's not like a new construction where you can kind of choose your solar orientation of your building, but if you can choose a property with that in mind, it's a good thing to do. Finally, a good real estate location. I guess that's really just a rule of real estate, where you want to have a building that's also not too far from manufacturers, where you can get to it pretty well, and will actually keep good value if you do retrofit it. And finally, you want to try to do a building that's also of simple shape. So a bit more about the design phase. Like I said, we started with the client from day one. We chose a property, and then we worked with various consultants to really start this design phase with various ideas in mind. So we did have an architect and sort of designer on the file by the name of Jeremy Green. He helped us with all the architectural drawings of it. And our energy modeling was made by HomeSol. We worked with Stefan there and his team. It was really great working with them, because we were reaching or trying to reach the net zero and net zero ready certifications. So we really started with a very good, I guess, integrated design process. We spent our time really working on that design. On the right, you do see sort of like various different scenarios that were built. I think it was the Volta tool that HomeSol used. It was really good to just try out different configuration, different levels of insulation, different windows, different levels of airtightness, and seeing what effects it has on the building performance. So we went through, I guess, a good 3 months of design where we went with structure and architecture and the energy modeler and myself, the contractor, really going back and forth to see what is going to be the full scope of the project. So this is the before and after basically of the project. We did start with a very leaky house. You see the EnerGuide rating at 179 gigajoules per year, and we were able to bring it down all the way to 46 gigajoules a year. And then we would add the solar production, which we'll look into after, and it would bring us to a basically net positive house, which is really interesting for a retrofit scenario. It's not really that hard. It's not really that easy. So we were very excited and very happy with the results that we got. If we see here, we do have a little difference in between both EnerGuide ratings for the typical house. It's because we did add a small part or a small, we changed a bit the volume of the house. So we needed to take that also into consideration. So the retrofit itself really focused on two big, I guess, retrofit terms or retrofit methods. First of all, we really integrated the concept of a chainsaw retrofit. Chainsaw retrofit is really in which a retrofit in which we cut the eaves off. Literally, we didn't do it with a chainsaw, but it's where we really try to bring that house back to sort of like a monopoly framed house or like a monopoly house with no eaves. So this, what you see in picture number one, where we cut completely basically all the overhangs, and we basically rewrapped the house from that point and then recreated some overhangs. And then we also worked with a Larson truss. I call here the modified Larson truss. It's not exactly a Larson truss. We'll see why. Basically, the building, being an old barn, had some sort of like very, very wide foundations. So on the exterior walls, we sort of had like a brick ledge there that was already protruding the building of about 8 inches. So we could basically build a wall in front of that. It was sort of like the house was asking to get a new coat of insulation. So we did basically a new 2x4 wall in front, which kind of resembles a Larson truss system. In terms of air tightness, we really started off with a high level of air tightness of 8.5, even though we've seen much higher. 8.5 is pretty high, specifically for a house that year. It's not that abnormal, but it's pretty fairly high. And we were able to bring it down already at the mid-construction at 0.75 ACH 50. So that was basically at this stage, or first picture here, that's where we had already reached 0.75. The final air tightness was 0.47, but then I guess then at the real final air tightness, we did 2 final air tightness. We went back up to 0.7. We had all the mechanicals installed, like the air intake, outtake. So there was a couple of other subtrades that also passed after that. We lost a bit of air tightness there, but let's say final result around 0.7, which was a very great improvement over the original 8.5. For us, air tightness is always the most important. We try to focus more on air tightness than insulation. Also, actually, insulation is really our third focus. It's always air tightness first, then windows second, and then we really speak about over-insulating the building. I guess the air tightness, really the approach that got us to those very low levels was really like redundant layers of air tightness. So we had on the exterior really 2 levels of air tightness. The first one being sort of like this first monopoly framing air tightness layer, where we kind of have really this easy continuous air tightness that goes from exterior walls to roof back to the exterior walls. And then the only transition point really is at the foundation, where we used a liquid applied air barrier. And On top of that, then we had another layer of air tightness. And then we also changed where we weren't supposed to really go too deep into the interior renovation, but we ended up having to open the interior walls. And we also added a interior vapor barrier. So that was like 3 levels of air barrier. At this point, yes, it was very redundant, but just with the first layer of air tightness, which was this first one, we were already at 0.75. So keeping that continuity really makes it easy. After that, it's not rocket science, but getting to that point is what is interesting. We really had a great strategy for windows and perforations. Windows in particular are usually one of the leakiest spots in the building. So we really focused on getting a great window details with interior and exterior tapes and some expanding foam. So it was really textbook material for the windows. And yeah, that's pretty much. Also, I guess testing early and often was very important. We did, I believe, a total of 4 tests in the house. So it's always important to know where we're at, to know, are we doing a great job or not? And do we need to double down on our efforts or not? Then the mechanical system, also very important. I mean, Ben showed that space heating and water heating was basically the big 2 consumers here in Quebec, specifically space heating. A lot of that is dealt with the envelope. So we're left with basically enough for a very small heat pump to be able to patch for the rest. And for the domestic hot water, we worked for the first time with basically a CO2 split system heat pump hot water heater, which is the Sandin Sanko, which was very interesting. So it's a CO2 heat pump that is, like it says, it's really a split system. There's an outdoor compressor and an indoor tank, and that is what supplies the hot water to the house. And that basically was also where we were reaching a point where we were doing the energy modeling and saw that, well, we can't reduce much more in terms of the space heating with insulation. Maybe our tightness, we could have lowered it more, but we were kind of like, the more insulation that we put, we're not really gaining that much. The big consumer was always the domestic hot water. So really going for this heat pump hot water heater really permitted us to get that net zero or net positive target that we wanted to reach. There is also, basically, when I say net positive, means that we do need to have energy production, which is a solar panel array of 25 solar panels of 580 watts. I believe the final design was about 14.5 kilowatts. And this is not installed yet. This is the last thing left on that building. We reached now, and that's why in that other EnerGuide rating, we don't see 0. That's because we're at net zero ready. And we plan on basically doing that as last step for the building. Here in Quebec, it's a bit hard to justify solar panels. We do have a cheap and very clean electricity. In this case, the solar orientation is perfect. The roof has already been restructured to hold the new solar panels. And clients also very keen on solar panels. So that's basically the next step for him to be completely net positive. So in terms of the insulation, we did, here's basically the details that we really worked with. On the exterior walls, we had R22 rock wool. That was in a 2x6 bats spaced at 24 inches on center towards the interior. That was something that we weren't really going to touch. There was already, I guess, fiberglass insulation. Why I said we weren't going to touch is because, well, we wanted to really, this to be really just an exterior retrofit. However, after doing a couple of openings to open up the window openings, the new window openings, or resize the windows, we saw a good smell of mouse poop and mouse pee. So it wasn't, we kind of decided then and there to really just open up all the walls. We were there, right? And to change that insulation at that point and re-add a new vapor barrier or vapor permeable, vapor retarder, let's call it that. So on the exterior walls, we do have basically that Larson truss, which is about 8.5 inches of insulation of dense packed cellulose, so bringing us to close to R34. On the roof, we had the same 2x6. We had basically rafters of like rough like real 2x6 rafters. And when we reopen the roof from the top, which we'll see in other pictures, we were able to refill that with rock wool insulation. So we had an R22 there. And then with 9.5-inch I-joist and a 2x6, basically creating overhangs, we had R60 of dense packed cellulose on the roof too. For the foundations, as I said, that's sort of like our first transition point. We had basically our air barrier being an a liquid applied air barrier, which is the Viscon by 475, where we were able to transition that and until that would connect basically to the exterior wall air tightness layer, and we added basically a 2x6 wall in front of that. And we also have a continuous insulation in our where we created sort of like a mechanical cavity with a 2x3 sitting on its side, so 1.5 inches of continuous insulation in front of that. So we had about R28 of rock wool there. Finally, the windows, we had some internorm windows, which were aluminum on the outside and basically full wood. And it was a triple glazing with a U value of 0.9. So what's important to note, I say carbon neutral. I mean, we do understand that rock wool is not carbon neutral, but we did use a lot of cellulose, and we were very happy to also use basically no spray foam in this part of the house. We did do an extension to this house, which we'll see in the pictures, in which we were very limited with space and we had to work with a bit of spray foam there. But for basically the bigger part of the renovation, we were able to be fully foam free, even around the windows. We try to avoid as much as possible spray foam. Why specifically here in Quebec, even Ben said it, our operational carbon is fairly low due to our hydro, which in terms of importance here, our embodied carbon really is of importance. It takes a bigger proportion of the cake, of the carbon cake of the building. So we really try to focus on every project to really keep that embodied carbon really low. So here are other project progress pictures of the project. We created those window bucks. It really helped us to get a good, first of all, ease of installation and continuing our air tightness super well. We had to basically, I told you we had this brick ledge. This was pretty much the same thickness of the brick ledge that the house already had. It was just in very bad shape. So we kind of re-poured a bit of like 1.5 inches of concrete on top. But you see that this house was already kind of asking for that new coat of insulation. And you do see that this wood is that OG mass timber that I love to call. So it's really 3 inches of wood. That's called here pièce sur pièce or Quebec frame construction. Here on the roof, like as we had seen on the picture, we did do that. We cut off the overhangs. We restructured all the roof rafters there by adding new 2x6s on each side. We were adding a considerable load to the roof, so the engineer did ask for to re-solidify or to re-sister those rafters on each side. We added a new layer after that of plywood, just so that a very thin layer, I think it was a 3/8 of plywood, just so that our guys could really work well on it to install the I-joists and the 2x6s. So that was not necessarily needed, but it was just really for guys to be able to work and go faster on that renovation. So this is the roof with the overhangs that we recreated. So the I-joists are right below that. And we see that here we have sort of that part where we had that extension, where we really decided to be that extension or that veranda would be really outside of the building envelope. So we treated it as it was outside, keeping that really the continuity of the air barrier behind it, and then creating sort of like a new building onto it. So it's really defined, having those defined areas of what is inside the envelope and what is outside the envelope is very important. And we really shine through with those details here. And yeah, so this is basically the end product. We see this extension here that was added to the back, to the front of the house. Very nice metal roof that we added, with a nice cedar finish, board and batten cedar finish, also mixed with the cedar shingles. So we kept that old charm to the house, and basically it's ready for that new solar array to come onto it. So that's pretty much it for the presentation. We'll be ready for questions.
Thank you so much, Fellipe. Just so everybody knows, I posted the link to the case study that Fellipe just presented, the case study on retrofitcanada.com. If you scroll up through the chat, you'll find that. But yeah, that was awesome, Fellipe. I'm just going to share my screen here, and then we can jump into the Q&A. Okay, so we like to start off our Q&A by having a technical expert who, with experience in retrofits, asking some questions of our guests. So today we have Peter Amarangan, who many of you know. He is the president of the Retrofit Canada board. He was a co-founder of the organization. And I'll let him get started. And just a reminder, there is a button on your Zoom menu that says Q&A. Please use that to submit your questions. We will not be able to deal with any that are just posted to the chat. So if you got a question, post it to the Q&A, and then do vote for the questions you like the best. That'll help us prioritize which ones we deal with first. So Peter, over to you.
Thanks, Tim. Thanks, Fellipe. Wow, what a great project and really good presentation. You answered some of my questions as you went through it. And I think my main overall question is, in doing this project, where did you find areas where you might be able to do it more cost effectively the next time? Like what improvements could you see?
Yeah, absolutely. Definitely cost was one of the biggest, I guess the harder parts of this retrofit. We did go over budget. And the hardest part really to control was all that was related to the roof. Working on the roof took much longer than we expected. So I guess that working on a better strategy there might be something that we would work, maybe considering an over-truss roof. Maybe would have reduced a lot of the work. On the walls, the exterior walls, that was super fast. We could have, like I said, if we knew that we were basically redoing also the interior, we would have maybe reduced one of the layers of air tightness. I mean, with 2 layers of air tightness would have been pretty good, or we could have revised a bit our strategy there. I feel like we did have a bit of redundancy there, but it definitely helped for the air tightness, but it wasn't all that necessary to have 3 layers.
And you know, there are a few things here that more sort of nerdy technical questions. I'm fascinated by how you dealt with the window air tightness, and just the actual details of those. I didn't see that in your case study. Is that something that we could get and maybe draw up for you?
Absolutely. I do have pictures where I have pictures and videos where I try to nerd out a bit more on details. Like I said, we love to install windows here at Retrofit too. So windows to us is a very important one. And well, essentially, if we want to explain it now, and yes, I'm happy to share how we do them, but we used, well, first of all, having that plywood buck, especially in a retrofit scenario where you have sort of like that new surface that is square, that is easy to follow, really helped us like tremendously during that install. So we do, for example, use 2 tapes, an exterior tape and an interior tape, both Siga Fen trims, window tapes, and they're fantastic. They work super well. They stick to anything. And once you install the windows, it's super fast. We like to work with an expanding foam tape too, that instead of basically, well, you acts as insulation and goes to fill pretty much every gap. Once you put the window in, the tape slowly expands and goes to compress everything. So then again, that creates another like redundancy layer where we have like almost 3 layers of air tightness. But for windows, it's so important. You know, there's windows are often the first place to leak in a building. And we also like took other precautions where we did put like a back dam to these windows and a sloped sill, because we do have that window buck that is basically square, but we had some sloped insulation that's usually used on flat roofs, and we kind of cut it off so that we could slide it into the window, and it kind of acts as a sloped sill there, and it was a very good detail.
Boy, that sounds great. I really, we should, if those are not in the site or in the case study, we should really make sure they get there. I'm just hearing you describe them makes me kind of excited. So, but I think
yeah, it's pretty exciting.
there are lots of other questions in the chat, and let's go to them.
Okay, we are going to start with Chris Olette. He is asking about, this is probably for all 3 of our guests, Ben, Fellipe, or Peter, but let's start with Fellipe. What has been your experience with radon mitigation with retrofits? Chris mentions that he is seeing higher rates of radon, but just with the projects here in Edmonton, but he's curious about your experience.
Absolutely. So for sure, the first step is measuring. As of basically for anything in this building, you need to know where you are, right? So for radon mitigation in this project, we did put some sensors in at the beginning of the project, and we saw very low levels of radon. So we decided that it wasn't as important to deal with in this case. It would require more work for the amount of radon that was present. So it wasn't really necessary in that build. But usually we just try to have that continuous vapor barrier and having good air tightness to really reduce that stack effect that could create or that could encourage radon to come back into the house.
Thank you very much. Peter, anything to add on that?
Yeah, so I just before this call was on a call with the National Research Council, who are doing a study on our Sundance deep retrofit, and the preliminary results are showing that if you make the building airtight, and we got those down to about 1 air change an hour, and install an HRV that's properly balanced and sized, you can keep the radon levels low and below well below the dangerous thresholds. So, I think to Chris, like, I'd be happy to talk to you further about how you about dealing with high radon levels in the course of a retrofit. It's the things that you do in a full deep retrofit will definitely help, but there are a few parts of that particularly if you've got a really poor basement slab and the connection to the foundation, that needs some special attention.
Awesome. Thank you very much. Just a reminder, I see some of our guests are raising their hands to speak. We are not able to deal with questions using the hand raising. Please submit them to the Q&A by clicking on the Q&A button. Our next question is anonymous, but it's asking, is it worthwhile to invest in a deep retrofit for a house that's over 100 years old? And I think specifically this question is getting at what kind of resale value does the retrofit add to the home in the context of the demand for older buildings.
Maybe.
So I'll let Fellipe go, and then Ben or Peter, feel free to.
Do you want to go first, Ben?
Sure. I was jumping the gun. Sorry there, Tim. I think in my mind, it really depends on the situation of the homeowner. if you're planning on being in the home for another 15, 20 years or more, and that home spatially meets your needs, there's no significant structural issues, a retrofit 9 times out of 10 or more often than that is going to be cheaper than tearing down and rebuilding. So there's that financial aspect of it. If the bones are good, a retrofit's a great way to do it. Also, it's looking at the impact of that retrofit work as well. If you're able to pull just an exterior retrofit, you're able to still live inside, then that's a great solution. It all depends on what work needs to be done, but 9 times out of 10, if you plan on being in the home for another 20 years, it's more worth it to retrofit than to tear down and build new. Fellipe, what would you add?
Yeah, basically that's what it was. I mean, the clients, it was their forever home now. You know, it's their retirement home. That's they're planning to be there for the rest of their lives, and they try to also keep it low maintenance, right? If you're doing a building that's well built, it's going to be low maintenance. You won't need to really be maintaining the rest of the house. You know, the house is functioning by itself as much as possible, relying the least amount as possible on the mechanicals, right?
Great. We got a question from Ronnie Araya, and she asked you to expand on the delivery method, Fellipe, asking, is this a design build? And any other details you can provide about the delivery method and how it helped facilitate the retrofit.
So it wasn't a design build per se, but it was very, very close. And that's kind of how we like to do our projects. Meaning we do have a big focus on pre-construction. We really, really believe that if we're doing all that work on paper first and really making sure that we have the right strategy, we'll have a more successful job site thereafter. So we tried to focus as much as possible, and the design side of things also excites me. We had some help basically, but maybe for the future of our company, design build will be something that we are offering. Yeah.
Thank you, Fellipe. The next one is also for Fellipe. It's from Andy Coburn. He starts off by buttering you up, Fellipe. He says your projects are so fascinating. And then with regards to this case study, he's asking whether running the new ducting, electrical, plumbing, etc. was challenging because of the structure of the building. And then the follow-up question was, were chases already existing that you could use?
Well, basically, you know, it's a 1.5 story, and we had we had basically sort of that knee wall, where behind the knee wall technically was exterior area, so it's space that wasn't really used in the previous house. Once we did that retrofit, where we kind of used or changed the envelope right from that knee wall, or the space behind the knee wall, to the roof plane, that was the air barrier. That space kind of became available as a mechanical chase to really help us work from front to back to the house, to go past that mechanical ventilation. Of course, we also had the basement where we were able to use a lot. I mean, it's sort of like, it's not a basement, it's a crawl space that's like 7 feet tall. So the basement really wasn't meant to be used as a living space. So we had a good place to distribute there. But with the amount of work that we did on the inside, it was also less intrusive to run the new ducting around. It wasn't too complicated, yeah.
Awesome. This other one's simple. It's from Marc Antoine. He asks if there's a way that we could get a hold of the model that you use for the humidifier.
Yeah, I think I don't remember exactly the name of the model. It's a Honeywell model. It's honestly fairly basic. Nothing too crazy there. It's not a vaporizer. I know there's different types of humidifier, but it's a very entry-level humidifier.
The next question is from Isaac Rudnicki, and he agrees with Benjamin's earlier comment that these can be expensive projects. And he asks, what, in your opinion, I'll open this up to Fellipe and then Peter. In your opinion, what are the biggest things that need to change in order for these projects to become more economically viable?
It's a great question. First of all, I think, well, the more we do, for sure, we're going to reduce up to a certain amount. You know, it's having sort of that knowledge and having, you know, if you're repeating basically those projects, you're definitely going to be able to lower the amount of or to optimize the operations on site. So for sure, that's going to help up to a certain amount. I think the rest really has to be in terms of how the market values it. So how is the market perceiving that as value? Whether a certification really helps for that, whether the government is kind of obliging some certain levels of performance for existing housing. How are we going to find ways to subsidize these retrofits, to finance these retrofits? I think that's really what's going to be the next step. Yeah, we can reduce the construction costs up to a certain level by creating, you know, by optimizing, but it's still an expensive retrofit. I think it's more of those other mechanisms and policy work that's going to help us get to mass retrofits. That and the rest of the whole panelization movement, that's really going to help us maybe accelerate those retrofits. The time on site and the labor, which is a big part of it.
Peter?
You know, I don't have a lot to add to that. That Fellipe really covered the bases. I think I really don't have anything to add to that.
Yeah, I'll add a little bit, and I speak just from my experience with Retrofit Canada. I've talked to dozens of homeowners that live in retrofitted homes, and these are generally, in almost every case, they are homeowners that they care about a wide range of things when it comes to these projects. Climate action is certainly one of them. Having a lot of certainty with fixed costs related to utility bills, which we cannot expect to be stagnant for the next 30 years. Like, they're going to change. We can probably expect them to go up. But then also just like you have it's just a better building. And 100% of the homeowners that I've spoken to, and almost every single one has spent over 150 grand in the retrofit. Every single one of them said they would never, ever go back to a code built house. Like, the buildings are just that much better. And I think it's just really important to consider that in your cost calculations and your like how you're prioritizing whether or not to move ahead.
I think if I could chime in really quick on this, I think one key aspect of it is we need to get better things framed up and planned for how we can roll out phased retrofits effectively, because there's a significant portion of the Canadian population that's not possibly ever going to be able to afford a full one-shot deep energy retrofit on their own. Government programs can help a certain amount, but how do we get systemic change in there as well, so these things are properly planned and phased, so we can look at doing the windows at one point and the siding at another point. And yes, it is going to cost more overall to do it in phases, but when we have a proper plan, we can be successful on it, and we can stretch that cost, that upfront cost, sometimes over more than a decade to get it done. But right now, if you can't afford to do it all at once, people are just replacing their siding, and boom, that siding's on there for another 30 years or more. Unless we've lost that chance for 30 years to add insulation, unless we want to prematurely pull that siding off.
Yeah.
Thank you, Ben. Another question from Chris Ouellette. Did you consider straw for the building insulation? And if you did, how did it compare with rock wall and cellulose in terms of the environmental impact?
I didn't consider straw. It's not something, I mean, it's something that we're not very exposed to here in Quebec. So that for sure, it's not something where we see a bunch of buildings. So I guess in terms of availability and I guess like initial learning curve wasn't necessarily justifiable. I know of a lot of great straw buildings that would be very, very carbon neutral. But here, really, our solution was to working with cellulose is not only one of the cheapest ways, but also a very, very great way to insulate and to get a good level of insulation. Initially, we were thinking of going with some exterior insulation, like a continuous rock wool insulation, but we were building it in the summer of 2024. And at least in the east part of Canada, there was a big rock wool shortage. So we kind of went to plan B, which was having more cellulose and creating sort of that Larson truss. So to me, I think cellulose is readily available, very cost effective, and carbon neutral. So it makes it a very good building product.
Great. Fellipe, how long did this project take from start to finish? I would go with your first meeting with the homeowner to completion.
So first meeting with the homeowner, I guess it was November 2023, and it went all the way until this November 2024. So it was basically a year, from discussion, pre-construction, and on-site. On-site, we were talking about maybe 4 intensive months and like 6 months total.
Okay. The next one is, and I hear this question come up a lot. Everybody hears about how much emphasis there is on air tightness with the retrofit, and this comes up a lot. The next question is often, how do you deal with the mold? So it's kind of a building science question, Fellipe, and you can deal.
Yeah, well, controlling your vapor is super important, right? A lot of it is dealt with this air tightness and your thermal barriers. It's all those barriers combined together. In a retrofit, what's hard is that we're kind of adding a new envelope to an existing envelope. So we really have to be careful with that to make sure that we really don't want to we don't want to create any moisture problems in that existing wall. So we like to work with also installations that are very vapor open, so that we can have a wall that's able to basically dry inwards or outwards. So using also those membranes or high performance membranes that help us get to that point. I think that answers the question. Like if there was mold in the house, we would treat it, let it dry out, treat it, and then rebuild on top of it. But there shouldn't be any more mold coming after that.
We have a couple more questions before we get to those. Oh, actually, no, sorry. We have a building envelope expert on the panel here. Ben, anything to add about mold and retrofits?
I think Fellipe captured some of the key aspects of that. I see Peter's got his hand up. He might want to add some comment as well to it. I think the main thing is to have a plan. Like, make sure, even if you do decide to use a less permeable insulation, make a plan for how that wall is going to dry. And the question also may have been addressing too, what do you do with mold you encounter too as you open things up? I think key aspect of that is get it all out of there, get any moisture down. Like, when I used to do building envelope work on site, I dealt with a whole lot of significant moisture issues in homes. And when we're removing any mold or rotted wood, we're going several inches past the actual damage and clearing that out and making sure we start with a good, clean base, a good position to go from. Fellipe's strategy in having multiple air barriers, the air barrier discontinuity is one of the key things that allows moisture to get into these wall assemblies and create issues beyond bulk water entry. So that vapor barrier is great to prevent that moisture from inside the home from getting out through the wall assembly, but that air tightness is key for mitigating any mold moving forward. And as Fellipe said, making sure that wall can dry. It does have a path to dry, and you have to plan for it, not just pray for it.
Thank you, Ben. Peter, you have your hand up?
Yeah, I think Ben pretty much answered it, but I think the short answer is these deep retrofits are an opportunity to really apply good building science to the whole envelope, and if you do that, you're not only going to warm up the surfaces where mold used to occur because moisture would condense on them, but you'll also prevent that from happening in the future by having the warmth at those air barrier points and making it airtight and allowing the new built-up part to dry properly.
Thanks, Peter. And then finally, question comes to us from a retrofitter that we know very well, Peter Darlington from Solar Inc. Calgary. Question for you, Fellipe. He asks, how did you vent the attic?
Great question. That was one of our hardest, I guess, building science decisions. We changed from a vented attic to an unvented attic. However, the roof was vented really on its plane. So we used sort of like a what's called an R-vent membrane, which is like a 3D membrane that usually we use behind shingles. So it creates sort of like a rain screen. And at the fascias of the overhangs, we were able to put a core vent to kind of be like an air intake on that roof. So it was kind of like we brought the unvented, well, it was really like a vented roof that went to be unvented, and then we just vented really that metal part. So really we would avoid as much as condensation as possible.
Great. Thank you so much. I just want to acknowledge that we actually have Mark Gibson as a guest, as a participant in the audience. He is the homeowner of this project, and he has been answering some questions that are in the Q&A. Mark, I really appreciate you jumping in. These webinars are generally, we have builders talking to builders. We are looking at a homeowner type webinar down the road here, and I am definitely going to be tapping Fellipe on the shoulder to see if he can put me in touch with you. So thank you so much.
Mark's a very sweet guy. I'm sure he would say yes.
Thank you. So that is the end of our webinar. I just want to invite everybody to stay connected with us and with Fellipe. He shared some contact info in his last slide, but you can find him at Retrofit Canada. No, that's us. Find him at Retrofit Construction online. If you Google that, you'll find his company, and he is very active on LinkedIn and has an Instagram account going. You can follow us on LinkedIn, Blue Sky, Instagram, YouTube, and Facebook, and then we're still on the dumpster fire that is X. There is a Deep Retrofit community on there, and we do post on X still. I also want to acknowledge our partners. So our founding partner, the Sundance Housing Co-op. We also have our original funder, National Resources Canada. And then the Alberta agency, the Smart, Sustainable, Resilient Infrastructure Association, has provided us with some awesome help with research and with getting our case study library off the ground. Alberta Eco Trust has supported our programs. And then again, Southern Alberta Institute of Technology's Green Building Technology Access Center with Ben Hildebrandt is an essential partner in this project, this webinar series, and with building our case study library. I want to thank everybody for coming today and for supporting us. Fellipe, thank you so much for the case study. And everybody, have a great Monday. We will talk to you again soon.
Thanks, everyone.
Thanks, everyone.
Thank you.
Another great webinar.